All right, so the type of cover and treatment. This is what I was telling you about the curve numbers and the tables. So all of your curve numbers are over here. So soil types A, B, C, and D. So on this one, and I'm going to see if I can scroll this in. It may just, oh, it does. It does work. Now how do I, oh, there we go. I didn't know you could do this in PowerPoint. So we have curve numbers. A, B, C, D is our soils type. So take a look at the number. If I've got open space, lawns, parks, golf courses, cemeteries, then we have a type A, 68. That's our curve number. If we have a type D soil, 89. Remember what I said, impervious area, I don't care what type of soil is underneath of it, you're going to have a curve number of 98. It isn't going anywhere unless it is impervious pervious pavement, and we can talk about that later. Now, so we also have, for example, streets, roads. You have paved, curbed, stormwaters excluding right-of-way. Again, all 98. But take a look at this. You have paved, open ditches, including right-of-way, meaning the green space. You have 83 to 93. So depending on what you're doing, so within a basin, you could actually break down the road as a sub-basin, the lots as a sub-basin, and you can actually associate their curve numbers. Now what you normally do is you go ahead and go, okay, this much area is roadway. It's going to get a curve number of an 89. This much area in that sub-watershed or in that watershed is going to be open space. And it's going to have poor condition. That means the grass cover, like my grass right now, Pahea, since we've had no rain, it's basically, I can see the sand underneath of it. It's got 50% grass cover, and let's say it's a really good soil, so it's a 68. So what I have to do is I have to do weighted averages. Let's say I have 2 acres of residential on poor conditioned open space, and it's, you know, one value. So I would have to weight the areas of these associated to their curve numbers. And we'll do an example. When you read through the TR55 urban hydrology for small watersheds, you will see those examples, and I will show you those also. Now, you also have in there, and I'm going to pull this up just to show you the different tables. You have 4 tables. You have one for urban, one for agricultural, cultivated, other, and then rangelands. So let me escape out of that and let me show you this. So this is part of the manual, and here's 2A. So you have also in here, I'm going to scroll down for the urban land, is the commercial and business. So at the top of this, take a look at what this says. Excuse me. Average percent impervious area. Okay? So you have 85%, 72% associated with these types of urban development. So if you have residential districts based on lot size, let's say I have 1/8 of an acre or less, so basically they're townhomes. It's got 65% impervious, and so my curve numbers are affected by that. Okay, so each one of these, depending on the lots, depending on the cover type, your curve number changes. Again, A's have a lower curve number than your D's. Hydraulic soils group is what I'm talking about. Now, you also need to take a look at the information that's below it. It's saying the average runoff condition in this is IA is equal to 0.2S. So we've already talked about that in the equation. It says the average percent impervious area shown was used to develop the curve numbers. Other assumptions are as follows. So you have to take a look at all these conditions that they are applying. Like this says average percent impervious area, look at comment 2. And then if you have an average percent impervious area, then you might need to go to figures 2-3 and 2-4. And then you have a comment 3 that says has to do with pasture lands. Comment 4 has to do with desert landscaping, and then comment 5 has to do with construction and also impervious percentages. So you have to modify those and not just directly use the curve number listed. It's like, all right, so imagine that you're in a subdivision. Rain falls on the lot, then it goes to the sidewalk, right? From the sidewalk, it goes over a little strip of grass, and then it gets into the curb and gutter, and then it goes down the curb and gutter into a inlet, right? Well, all of those aren't completely connected. It goes grass to concrete to grass to concrete, and then it's all concrete. So that's also called directly connected. When the rain hits the ground on the lot, is it hitting impervious area? Not on the grass, no. So it's not directly connected to the discharge point. But let's say I'm in a parking lot and we're at Home Depot, and you can see middle of the parking lot, those big structures, you know, the H boxes, the F boxes that are in the middle of the parking lot. Water hits the parking lot, goes into those storm structures, and then discharges to the pond. It absolutely never hits grass. The water droplets that hit the concrete or asphalt go directly to the grass or directly to the pond. So that's directly connected impervious area. So that affects how the runoff is. So when we're looking at this, and we've talked about, oh, let me pause right there. When we're talking about this, we're talking about the percentage is impervious. And we're talking about using the graphs, and I'm going to go forward just to show you. We're talking about using these graphs here to modify our curve number values for when there's impervious areas connected. So it says accounts for percent of impervious areas and how the water flows after it leaves the impervious area. Is it connected to a closed drainage system, or does it flow over another area? Okay? So if it's in the middle of Home Depot, it is directly connected to a closed drainage system. It goes into the pipes, into the underneath the ground, and then discharges directly into a pond. So let me go back. Now, when we're talking about hydraulic condition, you're actually talking about poor, fair, or good. Now, to determine whether it's poor, fair, or good, you need to actually go to a site visit. You can't just do aerial and look down. I do a lot of Google Earth when I look through. It gets you started, but it's nothing like going out to the site and actually seeing what the ground looks like. So good condition means that the grass or the ground is covered more than 75%. Right now, like I said, my yard is probably 50% sand and 50% dead bahia grass. All right. So antecedent moisture or antecedent runoff condition. It's based on whether the event has back-to-back storms or not. In this, the index of runoff potential before a storm event is the antecedent runoff condition, or ARC. ARC is the attempt to account for the variations in curve numbers at the site from storm to storm. Okay, so in table 2.2, they're using the average ARC. Okay, for the applications. They're assuming that no storm events already previously occurred, or we're assuming that the ground's already saturated to a certain point. Okay, we talked about that. Assumptions. So the tables have specific assumptions associated with those. I'm not going to go over these. I want you to take a look at the TR55, the Urban Hydrology manual. The Urban Hydrology for small watersheds. For whatever reason, I can't keep that in my mind today. All right, so take a look at those. So we can modify our curve numbers based on the connected impervious area. So you're looking at 50% impervious, hit a curve number, and then it'll come over and it'll actually increase your curve number. So the more imperviously is connected, the higher the curve number needs to go. Okay. If impervious is 30% less than 30% but not connected, you use these graphs. Now this is really big on commercial developments like gas stations. Subdivisions not so much. A lot of it is greater than 30%, because when it hits the roads, you're already hitting going into closed drainage systems. Okay, now here's the other thing. You can use, and I've never used these graphs ever. I would rather use an equation. I can plug in the equation and then I don't have to guess between these two little lines. I'd rather use an equation. So I just plug my knowns, my precipitation, my curve numbers, figure out what the S is, and then I'm set. But if you use precipitation, you could say it's a 4-inch rainfall, I hit a curve number of 75, and then it runs over here, and that's my runoff. I'm just not a fan of these. Most people call them nomographs, but I'm not a big fan of them. That's just me. You also have tables. And then with the table, instead of just using the equation, then you have to do interpolation. So the rainfall, 1.8, 2.0. What if I have 1.9? Then I have to interpolate. Nah, I'm not a big fan of interpolation. I can do it, but again, I prefer to use the actual equation, and I'm set. Back to equations. It goes over the assumption of potential rainfall or potential retention of water in the ground, or even some type of abstraction. And there's the equation. Okay. Limitations, curve numbers describe average conditions. So you're just best guessing it on picking one number for your site. And most of this is done based on test trials. Somebody will actually take a rainfall, like when I went to school, we actually had a rainfall simulator, and it was just a machine over about so far off the ground, and it would pour water down onto a ground, and they would see how much water would hit the soil, different types of soil, and how much would run off different types of grass. So it's empirical tests. Okay, rainfall runoff equation doesn't account for the rainfall duration or intensity. Initial abstractions, again, agricultural studies. We did this when I went through school, again, because my degrees are in agricultural. Okay, but they started to develop. They decided this was such a good idea. They just started to develop for the urban development, all your subdivisions and such. Okay, so if there's a significant storage depression, like if your site, like a subdivision, has a wetland on it, it actually has storage available to it. It's just the ponding effect. So you need to take into account that. Okay. The curve number produces less accurate when the runoff is less than a 1/2 inch. Okay. So the more it runs off, the better, the more accurate that the equations or the method is. Okay. Procedure overlooks large sources of groundwater. And lastly, the procedure is inaccurate when weighted curve number is less than 40. And that's very rare. A curve number less than 40, somebody's going to question that. That means most of the ground is going to be grass. And most of our development doesn't go from grass to more grass. It usually goes from grass to a subdivision, grass to a commercial development, grass to something like Disney. Okay, so it's very rare that it goes from a curve number that's low to staying low. All right. They're going to be the TR55 examples, and let me check this. The examples are in the book, so I want to open up this back so I can show you. In Chapter 2, Estimating Runoff, if you scroll down, it's got the same stuff that I was showing you before. Like I said, I'm going to ask you some questions on that. Maybe. Okay, so it goes over the limitations, and there's a few examples. For one of the examples, it says the present cover type is pasture, good hydraulic conditions. So if you look at the examples listed, here's the example 2-1. So the soil type was B, the pasture was good condition, so the curve number was 61. And then it says, okay, out of 100 acres, 30%, or whatever acreage, 30% of it was a pasture, soil type B, so it drains pretty good, and a 74 for a pasture with a soil type C, and it's 70%. So if you look at this, what it's basically saying is that out of 100%, the weighted average for those two, remember that 30% was at a 61 curve number and 70% at a 74, then the weighted curve number is going to average about a 70. Okay. Now, Some people, if they get a decimal, depending on how conservative they want to be, if it's, 0.5, then they'll go ahead and round up and say 71, because they would rather design for a little bit higher in some instances than design too low. Now, is that one going to make any difference? Probably not. All right, so I want you to take a look at those examples, and I'll be asking you some questions in the homework about these examples, and I'll ask you how to do a few on your own. Remember the TR55. And now here's the other thing. I found a typo in one of the TR55 sheets that are in the TR55 worksheets. I didn't make these, but there's a typo in one of them I've already seen, and I didn't do it. I'm just saying. So you take a look at sheet 21A, and then you can start filling these in. So I'm going to have you all work on those to work on the weighted. Now, here's the thing. Don't rely on the sheet, because I'm going to ask you probably on a homework or a quiz or something to be able to do the math on your own. It's not hard math, but I do want you to know how to do it. Just don't trust a worksheet. All right? So I'll go ahead and stop there for right now, and let me switch and... Yep, I'm going to stop there for right now, and then we'll continue on to the next lecture topic.